Mike Coons. Mike, where are you from?
From Durango, Colorado.
First, where'd you start out?
I grew up in Maine.
And so Durango, Colorado, I don't think of that as a particularly heavy oceanographic area or university. What did you study in university?
I did electrical engineering and computer science, and brought me into the oceanographic world just through that.
So given an electrical engineering and computer science, what's your role what's your day like? What are sort of the projects you tend to work on here on the ship?
We're kind of in charge of all the scientific equipment, all the gear that goes over the side of the boat, and all the computer equipment, data processing stuff on board. So we do all sorts of stuff, anything from wiring up, $1 million instruments that go down that take water samples.
I've seen you were rewiring a drone.
Yeah.
You've worked on ROVs.
Yeah.
We'll get to that in a second. And then you also write computer programs, coding.
Yeah, for data acquisition. And
what do you like to do more? Do you like to be out on the deck fixing something, in the shop fixing something, or sitting in front of the computers writing code? What's sort of your favorite?
That's the great thing about the marine tech job is I get bored doing any one thing all day, every day. So it's kind of a mix, and it's great to go outside and work hands-on, get dirty, and then come in, maybe write a little computer code, wire up a whatever drone, helicopter. Yeah, it's just a little bit of everything every day.
Very cool. So we've talked a little bit about mapping, and we talked about sonar and how this works. And now we're in the science control room, and you and I are on from midnight to 4 a.m. That's 4 hours. What do we do during these 4 hours? I know what I do, and it's usually drink coffee and make the next playlist. Because we do have very good playlists here in the Science Control Lab in the middle of the night. But we've got the maps here. Why can't, as soon as the sonar scrolls over it, why can't we just say, yep, it's mapped, and then we're all done?
Well, so, up here, we basically drive over it. The sonar is pinging, making noise in the ocean, and it gets, feedback back. It's listening to its ping that it sends out. It comes back. And that's good and all. It collects all that in raw format, but there could be lots of noise in it, and kind of takes human intervention to kind of stitch all that data together, remove the noise, and just do a bunch of editing on it. So we basically sit here, and as the boat moves along, we edit all the data that we collect.
So we've got the multi-beam has 432 beams going down, correct?
Yes.
So as those 432 beams go down, and then they come back, some bounce off random things, some get lost in the mix, and they show up. Like I see there's these random dots somewhere when we first get a file. They're random dots. And then we use the mouse and we actually lasso them and we reject those pings. Is that correct?
That is correct. Yeah, I don't know if you can see this screen here, but this is a representation of a little piece of seafloor, and each of these dots is a return off a single ping. And we just kind of go through and take the ones out that we don't want.
So have you been on the ship before?
No, this is my first time on the Falkor, actually.
First time, but not your first time doing multi-beam mapping, correct?
That's correct, yeah.
Where else have you been? What else have you done in the last year? What you said, 14 years you've been in marine tech?
Yeah, about 10 years marine tech.
10 years, okay. So where have you been?
Been working on ships all over the world. Spent a lot of years down in Antarctica, a lot of years up in the Arctic, some time in the Caribbean, and just kind of all over the place.
Do you like warm weather or cold weather more? Antarctic or Caribbean? What's better?
Well, I've done so many years in both polar regions that I'm kind of ready to hang out in the sunshine.
Okay, so I'm kind of with you. I like sunshine too. So one of the questions that just came through, we've got the map here, but then over here, now this is something that I definitely don't understand. There's a bunch of, is that data coming through? Is that code? What's going on there?
Yeah, so that is behind the ship right now. We're towing an instrument. It's called a magnetometer. It's maybe about this big, and it looks like a missile that Wile E. Coyote would
And it's
use.
got little wings on it, like
yeah,
these.
It's got little fins, just like a.
And so the fins actually drive it down, right? And so it's something like how far?
It's maybe a meter under the water. So
it's only a meter under the water. Okay.
Yeah, it's kind of getting dragged along the surface, and we drag it behind. And it's basically measuring the magnetic field of the Earth. It's called a magnetometer.
Right, that makes sense. Okay, even I understand that.
Yeah. So as you guys know, probably the Earth is polarized.
Yep.
South pole. And yeah, it's just kind of reading the magnetics of the Earth, and you can actually you could find metal objects if you're in shallow enough water with it. But for this purpose, they're just kind of doing that as from a geology standpoint.
So this is, why is that important to what we're doing here with the mapping? Why is the polarity and the magnetics of the Earth important to the mapping that we're doing?
It's a better question for the scientists. I just make it work.
Yeah, okay.
It does tie in with the geology. When they see different formations, there's always magnetic anomalies. So the world has a general, certain places of the Earth that should have a specific magnetic field.
Yep.
Due to the way some geologic formations form, it might make anomalies that they can then tell what came from there or what came from where. And I'm not the best person to.
But you also have variations for navigating on a compass. You have a certain variation, right? Amount of degrees magnetic versus true. So will this magnetometer help us determine that variation?
To some extent. I mean, not us on this ship. No.
Okay.
But as far as worldwide mapping goes, and they do look at gravity and magnetic data, and it's actually the U.S. military used a lot of that information.
Really?
For all of their comms and navigational stuff.
So usually, and I'm going to ask the kids. I think probably have some more questions. Do you have any questions for the kids? These are seniors in high school. Do you have any questions for them?
I don't know.
No? All right. Think about it. What questions do you guys have?
So if your sonar has 432 beams, how would that compare to the fish finder I have on my boat?
So if this has 432 multi-beams going out, how many beams does a commercial fish finder have?
One.
Yeah. Single beam.
Yeah, so you ping down, it hits the bottom, comes back up, and it tells you how deep you are. Whereas this goes out away from the ship, and you're actually, so you're basically pointing 400 and whatever sonars at about a mile to 2 miles, depending on how deep you are in width across, and you're getting depth soundings from that whole swath of the ocean floor rather than just the point below you.
And would the commercial frequency be different from the frequency we're doing with here? What are we on? We're 12?
This is 12 kilohertz.
This is 12 kilohertz, okay.
No, I'm sorry. This is, we're on the 32 kilohertz here. Yeah, 32.
Because we're very deep.
Yeah, commercial ones are usually 50 kilohertz is kind of standard.
Okay.
Yeah, they all vary, but somewhere in the same.
So
frequency.
Does that 50 kilohertz put out a wider or narrower swath?
Narrower, but it's only looking at one particular spot on the ocean floor.
All right. Yeah. Next question.
Brock, I have a question. No one's going to ask a question.
Go for it, Andrew. Yeah. Andrew, you there?
What was going on?
I think you guys might have muted yourself by accident.
We might have muted ourselves.
No, not Falkor. Sorry, Martha's Vineyard has muted
okay.
themselves.
Martha's Vineyard.
Okay, we should be back.
Oh, you're back.
I'm just curious if the ship is sending out any waves, like what you call SAP waves, which would go beneath the surface and map with beneath, like in terms of oil resources or stuff like that, in terms of geologically wise, not just sonar rays, but I'm trying to figure out what's beneath the surface of. I don't know if it's a question for the science.
So Andrew was asking a little bit about what's beneath the surface. Can the multi-beams look at sort of the rock floor or oil deposits or anything like that? We've talked a little bit about backscatter. Now that determines what sort of bottom it is, correct? It can show us how hard it is, how soft it is, sand versus coral.
Yep.
Can you guys see right up here the gray bit that's going by just to right next to the multi-beam? So what are we seeing on the as far as backscatter? What kind of seafloor are we?
Yeah, so I mean that's going to be pretty rocky there. to get even further from that, they do seismic work, which actually they just have huge air guns that they tow behind the boat, which I've worked on a couple of those ships. And they
Wait a minute. Huge air guns?
huge air guns, the size of this entire room. There's basically a big piston.
Is that like a big potato gun? Like
Exactly. It's a huge potato gun, about the size of this room. It gets fed from an air compressor.
wow.
Blows out a lot of noise at a very, very low frequency, and that penetrates miles under the ocean floor, and that's actually how they find oil in the ocean floor.
Now, I've read a little bit about this. Are there certain studies that would suggest that maybe that's not the best thing for marine mammals?
There are studies that say that, and they actually, on those ships, they always have a marine mammal observer.
Yep.
Whenever and all they do is sit there and, they keep watch for any kind of mammals. Anytime they spot a whale, porpoise, whatever, all operations shut down until long after they have disappeared. So it's,
Do you, from your standpoint as marine tech, do you think that it does damage to marine mammals?
I can't say if it does damage or not, but it definitely gets their attention. A lot of times when we're either towing something, air guns or sonars or whatever, you'll see dolphins or whales come up and they'll follow it for hours and they'll just kind of trail behind the air guns. And I don't know if it affects them adversely, but they're definitely drawn to it. So
Have you ever been in the water when one of the air guns goes off?
no, you don't want to do that.
You don't want to do that, but it's okay for the whales and dolphins?
I don't know.
What do you guys think? Is an air gun harmful to whales or dolphins?
Yes.
You would know, wouldn't you?
All right, it looks like we've got one last question. I got time for one last question. Anybody?
Yeah, I have a question. All right, so how, when you showed us that gray thing on the top screen, what's the other colors
Yep.
represent?
Below it?
Yeah.
So what's this going on here? We've got the backscatter, and then what's going on right there?
Yeah. So we have a little unit about this big. It's basically like a $100,000 iPhone. It has an accelerometer in it, and it tells how fast the ship is pitching, rolling, and heaving. So just basically the motion of the ship. And the sonar has to kind of counteract because the sonar beams are going to be going like this. So
Because the waves are moving the ship around.
Yeah.
So basically, what it's doing, that's measuring how much the ship is moving and then trying to keep the multi-beam in one place.
Yeah.
So it's not rocking up and we're getting all sorts of bad data, because that would put more data for me to clean up while you sit here and drink coffee.
much more,
Okay.
yeah.
All right. I have one last question for you guys. Today you learned about officers, engineers, interior, marine techs, scientists. What do you guys think? What's the most interesting aspect of the ship to you guys?
Engineer.
We got one for engineer. What else do we have?
Techs are
Engineer.
pretty cool.
Engineer, techs are pretty cool. All right. Awesome. Well, listen, I really appreciate you guys coming with us into the Science Control Lab and checking things out. Mike, thank you for your time.
Thank you, guys.
Let you get back to your playlist and your coffee. And I look forward to talking to you guys again soon, all right? Take it easy.
Correct.